Question number 1. Uh, what I'm going to do, I'll be like discussing this in detail. And also I'll show you the mark scheme answer as well. I want you people to write in detail discussion in your paper, right? Okay, first one, forms a stable ion by gaining 3 electrons. First of all, you need to figure out gaining. If it is gaining, it has to be a non-metal. Should be a non-metal atom, right? So non-metal atoms are in the group numbers above 3, right? So if the group number is 4, it needs to gain 4. Group number 5, it needs to gain only 3. Group number 6, it needs to gain only 2. Group number 7, it needs to gain only 1. Group number 8, it doesn't have to gain electrons because it already has 8 electrons. That's the theory. Thereby, 3 electrons are needed by the one which is in the group number 5. So the group number 5 element is phosphorus. This is extracted by hematite. All right. You can't forget hematite, right? If you forget hematite, I'm not going to scold you, but let me give you a hint. Have you ever heard this heme word, heme word, right? Have you ever heard the word heme? Heme, heme. Okay. Have you heard about hemoglobin? Hemoglobin,
Yes, sir. Hematoma අහලා තියෙනවා.
yeah, that's also related to what? Huh? Okay. So hemoglobin is the one which transport oxygen in your blood. Why it's called hemoglobin? It has globulin protein and the heme group. Heme means iron, right? Okay. Heme means iron. All right. So what do you call iron deficiency? What do you call iron deficiency? Huh? Anemia. Correct. Right. So if you know these different words that you can use to remember stuff, right? Hemoglobin. That's because the protein, globulin protein has heme group. Heme group means iron. Fe2 plus or Fe3 plus. Basically Fe3 plus, right? So is extracted from hematite is iron. Forms an ion which gives red-brown precipitate. Red-brown precipitate. The current band hemoglobin, right? That means it should contain what? Fe3 plus iron, right? Fe3 plus is the cation, gives you the red-brown precipitate. In qualitative analysis, you get iron 3 hydroxide. Iron 3 hydroxide. Okay, you need to write those things, right? You must be writing when I explain it like underline. You didn't come at all. Okay, bye. Then the red-brown precipitate addition of ammonia. Then again it's iron. They are asking what's the element only, right? Each element, right? They don't ask, okay, what, which iron? Mauli, I can't see you. Has chemical properties similar to those of calcium. Chemical properties similar to those of calcium. Now, how do we know? How do we know things are similar in chemical properties?
Same group.
Right? They are in the same group, right? Group properties. Okay. Now, if you take beryllium, magnesium, calcium, and then you have strontium, barium, radium. These are the group 2 metals, right? We put elements into group because they have the same number of electrons in the last shell. Okay, they will have like, this is like 2, 2, this is 2, 8, 2, this is 2, 8, 8, 2. And after that, you don't need to write the configuration, but finally they have 2 electrons in the last shell. If you have the same number of electrons in the last shell, right? Last shell electrons will decide the chemical properties, right? Will decide the chemical properties. You have the same number of electrons in the last shell, chemical properties are very similar. Chemical properties are very similar, right? Thereby, the answer for calcium here is magnesium. Yeah. Stop mind wandering, quickly write down. Are you loving each other? Kita join dulu. Okay. Can have lubricant properties. Do you have carbon? Yes. Normally lubricant we learn carbon, right? So the carbon is there. So then the answers for the first question is like this. I'm not going to rush today. Like we can discuss slowly. I think we have enough time to discuss and also to do the care, right? And online students, soon after you are done writing on the particular slide, I'm not going to give you the screenshots, right? Let me know whether you are done or not. Plus, I will display the marks. Everybody go. And now you can't see anything. Okay, next one. This question is about halogens and halogen compounds. A drop of bromine liquid was placed in a sealed jar, and after some time, the color of bromine had spread throughout the jar. Okay, 3 marks. Right, so inside the jar, like you put bromine liquid. Let's say you put some kind of a lid, and this red-brown liquid, bromine, its element color is a red-brown liquid. Everything in this paper is red-brown, no? Red-brown. And then this has, the color has spread everywhere. So there are 2 processes happening. First of all, bromine from liquid, it has to go to the gaseous state. What do you call that process? Liquid gas evaporate. Right? So the first thing should happen is evaporation. Evaporation. How do you explain the evaporation? Right? High energy particles in liquid state, escape to gaseous state. Okay, now I don't know what's the maximum answer is, but I'm writing things in detail. Right? So evaporation word, I just explained. right? Then once the evaporation has happened, in order to have the color spread, then the process called diffusion should happen. So secondly, it's a diffusion, right? So then diffusion, that's the movement of particles from high concentration area to low concentration. Particles from high concentration area to low concentration. Right? So I gave like in detail answer. Right? And why does it happen? That because of the random movement of particles. Gas particles are always in constant motion in all directions. Right? So they can collide and move into the space available. All right, next one. Complete the table that about the appearance at the room temperature of the elements group. So you know that chlorine is a gas, bromine is a liquid, and bromine is red brown. They haven't told that, no? Okay. Red brown. And iodine is what's the color of iodine?
So it's brick
Huh?
red.
Red? Iodine?
Black.
No. He is correct. But that is when iodine is dissolved in kind of a solvent. When iodine is in crystal forms, because we are talking about solid iodine, right? It's not just black. What is it? Black. Shiny gray color. Or gray, sorry. Iodine crystals are shiny gray crystals. You know, I'll tell you why. Let me tell you why you forget it. No wonder you forget it, right? Why? No wonder you remember that as brick red methods, because betadine, which is the ointment of iodine, is like brick red color. That is when iodine is dissolved in something, like in an organic solvent, in a cream, or in aqueous solution, right? But the solid iodine is gray shiny solid. Right. Predict the appearance of astatine. That's the one now you can see go down the group. Green became brown, brown became shiny gray, right? So then it's going to be what? Black, because the color goes dark down the group. Color goes dark, right? Color becomes dark. Chlorine is bubbled into aqueous potassium iodide. Chlorine is bubbled into potassium iodide. Tell me which element is more reactive, chlorine or iodine? Chlorine or iodine? Chlorine. Iodine. Chlorine or iodine? Okay, let me give you a hint. Do you know the most reactive nonmetal in the periodic table? Fluorine. Disastrous. You can't even put fluorine into water. It reacts with water and produces oxygen gas. It displays oxygen from water. Halogens wala reactivity at the top. When you go down the group, it becomes less reactive. Class ekedi varadunata poddakkat upset wenni pa, because that will make you to remember. Right? Some of you remember by making mistakes. Taking the tamai samara and kochchar padam kalat matha hitting නැති, because when you are studying, you're not making mistakes. You are just reading and just try to by heart everything. You're not making mistakes. But when you talk, when you go wrong, you're making mistakes. That mistakes will help you to remember. Right? Right? There's nothing wrong. Okay? And all right. So then chlorine is more reactive than chlorine is more reactive than iodine. Thereby, chlorine will say, how dare you stay with potassium? Potassium is mine. Here I are, no potassium. And then iodine is kicked out of the compound, then it becomes iodine. In order to do that, you need to balance this. Listen. Right. So is explain listening is the most important skill. Chlorine is a gas which is green color. Now iodine, now his point. Iodine is made in aqueous solution. That is brown. Iodine is dark brown in aqueous solution. Dark brown in aqueous solution. Right? Thereby, describe what you would see. It was a colorless solution, potassium iodide, you know, one of the well-known reducing agent, by the way. It will turn into iodine. Iodine is dark brown. So then what do you see? The colorless solution. Colorless solution turns brown. Right? And construct an ionic equation. Right. Okay. Construct the ionic equation. Let me help you how to write the ionic equation in this case. You know, chlorine is anyway, it's a molecule. You can't break that into ions. Potassium iodide, you can break that into ions, potassium plus iodide ions, because it's ionic. Ionic compounds which are soluble in water can break into ions. Right, so you get 2 potassium ions and 2 chloride ions. Why? You have 2 potassium iodide. You break that into 2 potassium ions and 2 chloride ions. All right, and then you break potassium chloride in the same way. A plus, Cl minus. And iodine, you can't break it into ions because it's a molecule. Molecules, you can't break them into ions. Now, what ion is common in both cases? Which ion is common in both cases? Potassium ion, right? Okay, potassium ion. So then you cancel out potassium ion. Whatever the remaining is the ionic equation. An ionic equation tells you what really happened here. Chlorine molecule has put iodine molecule out, right? It has made iodide ion to become what? Chloride ion. So chlorine iodide, chloride iodine. Together. That's straight in the question. So sometimes they ask, but here they haven't asked. Okay, I can't see now many of you guys. Last morning. Even my explanations, it wasn't full. May astatine theorem. It's a black name, black mocha pen on it. Solid pen on appearance kiwama. Appear physical state take up down. Black solid. It's about 1 mark thing. Sorry. Sometimes you might have written black, but no marks given because it should be black solid. Yes. Right. You can't assume that examiner would think about it, right? You have to write it. Okay, so let's check. The answers are there. You can double check. Let's look at the answer given for that explanation. Look at the way the marks given. any three from evaporation, particles with highest kinetic energy escape the liquid. I gave you that point. Right? Particles move randomly, intermingling the particles, mixing with particles, right? From higher to lower. So any three will be accepted.
Sir,
Yeah.
what do you mean by intermingling?
අර ඔයගොල්ලෝ මේ දවස්වල front gate එකකින් එළියට එන්න ඉස්කෝලේ යනවා එහෙම. පාට දැන් front gate එකකින් එළියට එනකොට මතක් කරගන්නවා. This is how particle diffuse. Whatever the space available, you mingle into that and
Very understandable, sir.
very understanding. Right? And you are going from high concentration area to low concentration area outside, right? But my worry is there are some big particles who are blocking the small particles. And those big particles are supposed to understand that they have to give more space for the small particles.
So, that those big particles are parents, no?
That you touch, right? Okay, that's my worry. They are searching for their small particles, not thinking about the small particles of others, right? Sometimes. Right. Okay, no? Right. Next question. Going to be a part of the previous question, and it's a calculation. Calculate the maximum volume of oxygen produced. Now, Lamai, you can follow the method that I have already told you. You have been asked to find the volume. Always those who do some pre-work before you do the calculation, we have seen more successful in getting final answers. Right? That's this what they ask. And what have they given? They have given sodium hydroxide, right? Sodium hydroxide moles given straight away. It's given straight away. So then it's basically jump from sodium hydroxide to oxygen. How do you jump from sodium hydroxide to oxygen? Stoichiometry. That is 4:1. And then you jump from N equals V/24, right? So then you find the moles of oxygen 0.037 divided by 4, right? And moles you can substitute into that equation. Divided by 4 is equal to V/24. So then the volume is 0.037 divided by 4 into 24. The answer is 0.22 dm cube. Yeah.
So, I wrote my answer to the figures and.
Go. Have they given? They have clearly told two significant figures. So they don't be too nice giving 3. Right? Significant figures දෙකයි නෑනේ. වැඩිපුරක් දෙන්න යන්න එපා ළමයි. වැඩි අප්සෙට් වෙනවා.
පට්ටයි sir.
හරිනේ? අර බැටරි එක සොන්නල දෙන්න. ඒක අපි Okay. Online students, I kindly request you guys to join the meeting like at least 5 to 10 minutes before, unless you have an emergency, to avoid the technical problems. You know, there are always the technology is uncertain. Problems. Therefore, make sure you log in 5 minutes or 10 minutes before, even before you double check whether you can log in. Otherwise, once I start my paper discussion, I can't be focusing on the matters that for the logging, right? So as a remedial, I'll be sending you the link, right? But I want you guys to join the teams properly by your logins, right? If not, please troubleshoot it well before, not at the last moment. Okay. So let's move into the next question. It's again calculation, right? Phosphorus is a non-metal in group 5 in the periodic table. What is the maximum mass of phosphorus? Look at this. Again, they are asking something out of the balance equation, that is mass, right? The connection to the moles of the one is M over capital N. They are asking this. So then it's easy for you guys to tackle the questions. But what have they given? They have given the mass of silicon dioxide. So they have given the mass of silicon dioxide, which is 300 grams. Sorry. Always I draw these circles on the symbols, they are the moles. Then 300 grams, you can apply N equals M over capital M to find the moles. Then jump again. For phosphorus, the jumping happens from the stoichiometric ratio 6:1. So doing all this stuff, you will be getting only 2 marks, right? So how do you find that? Moles will be 300 grams divided by silicon dioxide molar mass. Can somebody help me to get it? 60 grams per mole, right? Therefore, you have 5 moles. You have 5 moles of silicon dioxide. Now I am jumping from that to phosphorus. Thereby, by using the ratio which is 6:1, and silicon dioxide 5 moles, phosphorus X. Therefore, X is 5 over 6 moles. Once you know the moles of phosphorus, now you can apply N equals M over capital M, right? So then it's 5 over 6 M over phosphorus. Be careful, it's 31 into 4, right? So then the M is, what's the value you got?
3.292.
103.3. Have they asked any number of significant figures? No, 103.3 grams. That's the answer. Okay. Phosphorus is a simple molecular substance, suggests 2 physical properties of phosphorus. All right. Okay. So let me go to the board actually to explain that. I'll be like quickly revising this thing to help the new students. Remember, when they ask physical properties, when they ask physical properties of a substance, right? What you need to do, you need to refer to structure and what? Structure and bonding. These are the mind maps that you need to have. Dulmika, Senushi, Ishak, German, Minelli. Camera is not on. Okay. Senushi says, okay. Right. Structure and bonding. Listen. So then you need to refer to the structure and bonding. Then you need to remember there were how many different types of structures in our syllabus? Can somebody tell me? How many? එහෙම මේ අන්‍යවගේ specific වෙන්න ඕනේ කෙලින්ම knowledge එක. Ionic තිබ්බා, metallic තිබ්බා, එහෙම බෑ. 4. Okay, not bad. That's a good try. Actually, we had how many structures? 5. What are the 5 structures? Let me explain you. First one, giant metallic. Giant metallic. So whenever you see a metal, right, it follows the giant metallic structure. So metals have high melting point, high boiling point, ductile nature, malleable, right, conducting electricity, and all these things due to the metallic structure. Physical properties are due to the structure. Okay, okay. So some of you don't know what are physical properties. Melting points, boiling points, electric conductivity, right, and thermal conductivity, electrical conductivity, thermal conductivity, density, are properties like that which are not related to chemical properties, are physical properties. So you have to go to structure and bonding from your mind. So then it should be giant metallic, or your substance can be what? Giant ionic. Your substance can be, yes, giant covalent, and all these three are going to have high melting point, high boiling point, high densities, except for some anomalies such as like metals. Mercury is a liquid. Sodium melting point is below 98. Likewise, there are small issues with some deviations are there. Apart from that, giant structures are going to show those properties, physical properties, right? Or okay. And if anyone has the screen share issue, let me know. තමයි මම කිව්වා මේ එතත් මේ chat එකේ දැම්මම සමහරවිට මම බලන්න පරක්කු වෙනවා. Give me that clapping reaction. Clapping reaction එක on කරලා තියන්න, then I know you need me to screen share it. හරිද? නැත්නම් මට chat එක පේන්නේ නැහැ ළමයි සමහරවිට. All right. So let me screen share it again. Some students are asking. නෑ raise hand නෙමෙයි. Raise hand එක මම අහනවනේ වෙන වෙන දේවල් වලට. Right? Put the clapping reaction, okay? Right. Hope you guys are okay with this now. Minali?
Sir, now okay.
Okay, right. All right. So then giant covalent, and then we have simple molecular. Simple molecular. Don't worry, I'll give you examples. Simple molecular, and then we have simple atomic. Simple atomic. Right? Examples. It's like this. Giant metallic. Okay. Zinc, magnesium, iron, right? Giant metallic, right? Giant ionic compounds. Sodium chloride, magnesium oxide, iron oxide, compounds made of metals and non-metals. So you have quickly, ionic compound, giant ionic, have high melting point, boiling points, right? Giant covalent, we have diamond, graphite, CD means carbon diamond, CG means carbon graphite, okay, capital G. And silicon dioxide, silicon, they are giant covalent. They will definitely have what high melting point, high boiling point, high densities and stuff. Simple molecular means their molecules exist separately, such as water. You know, water is a liquid, such as oxygen gas, carbon dioxide. They are gases, bromine, liquid. Even iodine is a solid, but still simple molecular. That's why it sublimes. It sublimes. It sublimes because the molecules do not get like, do not form very strong bonds, right? They go to the gaseous state easily. Simple atomic are coming under noble gases. They have very low melting point and boiling points, noble gases. Is that clear? Now, just suppose you found two things having the same structure like sodium and magnesium, then refer to the bonding, right? If magnesium has higher melting point than sodium, both are having giant structures, then you can't explain why they are different because both are having same giant structure. Then refer to the bonding. You basically say magnesium has stronger bonds than sodium, stronger metallic bonds, right? So then when it is structure and bonding, physical properties, refer to the structure and bonding. And then suddenly you remember the 5 structures, right? 5 structures, right? So now day by day, I will give you short notes like this. Now we are not doing the MCQ discussion. Now the discussion is deeper, right? I'll give you more points. And we are improving the revision program every day. You can see now today we are using different technique, more mixed techniques, and promise you we have more things are coming. I'm going to, now I don't want to have 2023 results less than 2022, right? I have my own goals, right? Ekinda oya බලෙන් fail වෙන්න try කරත් I will force you to get an A, right? So then I won't give up on you, right? Parents ලාට පැනලා හරි ගෙන්නලා වැඩේ කරනවා if you are permanent staying in the class, right? A star 9යි A 6යි. Then what? ඒක තමයි. I want minimum 9 A stars, minimum 6 A's, and I don't want anyone to get B or C also. Right? So I will try hard on you. You give your effort, right? Olange parents are on the support karo, then it's going to be definitely successful. You know, it's a very hard thing. Yet I don't want to stop at lower target, right?
No terms and conditions.
What?
No terms and conditions.
Yeah. Conditions apply. Right? The condition is I told the conditions which you have to stay in the class permanently. That's pretty much the ban. ඔයා දවස් දෙකක් විතර ඉන්නවා ඊට පස්සේ එනවා ආපහු මාසයක් එන්නත් ඉන්නවා ආපහු වෙනවා එතකොට මොකද කරන්නේ හරි okay now okay come back to this point again. Okay, we got deviated little. Let's go back to this slide. Right, physical properties, structure and bonding. There are 5 structures. So whenever they ask some properties, physical properties, suggest 2 physical properties. And then you have to quickly figure out what is P4. They are very nice. They have told what? Simple molecular structure. Simple molecular structure means it is going to have what? Low melting point, boiling points. Low melting points and low boiling points and poor conductivity of electricity, poor conductivity of electricity and even heat, right? Electricity and even heat. Low density, low density, low density. Okay, using ideas about structure and bonding. Why calcium phosphate? Earlier they gave the structure. We have to decide. Now they don't give the structure. You have to quickly decide, this is metal and non-metal, therefore this is ionic. If it is ionic, it has to have high melting point. The reason they are using, you need to now explain why does it have a high melting point. Now you are going to say calcium phosphate has giant what? Giant
Ionic bonding.
giant ionic bonding. There is no meaning for that. Giant ionic structure. Giant ionic structure. Right? Cations and anions are, and anions are strongly what? Strongly attracted or bonded. Since I have mentioned its ionic giant, I don't have to mention it again in the second point. Right? Attracted. So a lot of energy is needed. 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 Right? And particle, the other one, okay. So it's number of protons 15. That means still it's phosphorus because protons decide the identity of particle. Proton number tells you what is the identity of particle. Okay. So it's unique. It's unique. So then phosphorus 50 and mass number can be found by adding neutrons and protons. So it's 31. Right? But be careful on this. We can focus on. Right? Look at the electrons. 3 extra electrons are there. Therefore, this should be what? P3 minus. So to get that mark is not easy. Right? For grade 9, if this question was given for a grade 9 kid, I would have given at least 2 or 3 marks for that itself. Right? But grade 10, they complicated. Right? Now we are learning collision theory later. Oh, sorry, right? Collision theory, there is something called something like that. Right? Collision theory, energetics, enthalpy, right? Now you are learning heavy topics. Right? If you feel like a big rock, something wrong with you, right? So then work hard. Right. So number of electrons here, first of all, number of protons 15, number of neutrons 15 and 15, right? Okay. So let me give you some time when.
Any question? See the fractional distillation of proven.
This time.
Every time it gets 2019 onwards.
Hospitals there are strong contract between calcium and phosphate and strong binding force. Oh, giant covalent structure, giant structure को कोई बात नहीं रहने. Giant hari lattice hari, as giant ionic. There is structure එක refer කරන්න ඕනේ. ඔයා refer කරලා තියෙන්නේ මොකක්ද කියලා? Bonding. Right? Thank you. One for structure, one for bonding, and saying that high lot of heat is that. Point එකකට mark කරනවා ළමයි මේ මොකද that will make sure that you guys are like writing Cambridge standards answers, right? One very important thing. Now, when you are in this revision class, right? Actually talking 25% of burden of studying is removed. Because I am revising many things on same day, right? Which you could spend somewhere around 2 to 3 hours to study at home. Within like 1 hour, I am reminding you so many things. Therefore, the revision class session, you must be prepared. And prepare in that thing in the class. Right? What I meant by preparing, Now, when I told you that you are going to get a paper 2, you must spare at least 1 hour for studying for paper 2. Right? And when I share you the topics, the key දෙනාද ළමයි අඩු ගානේ reaction එකක් හරි දාන්න. When I share you the topics, I don't know whether you guys read it or not, right? Whether you, right? At least you put a thumbs up, then I know that you read it. Right? කොහෙවත් නැති විකාර වලට නම් උඹ දවස පුරා reactions දානවා. මේ වගේ important communication එකකට දාන්න නෑ ඔයගොල්ලෝ. Right? I'm not jobless to check whether this particular message information බලලා whether you have seen this message or check මට ඒවා කරන්න වෙලා නැහැ. As students, be prepared for this revision class to get the maximum output. Right? දැන් මම topics ටික share කරා ළමයි දෙතුන් දෙනා ඒකට respond කරන්න. Okay කීක දාන්න ඕනේ නැහැ. That's all right. I don't need that. But at least, right? මේ reaction එකක් දාන්න ඒතර අපි දන්නවනේ මේගොල්ලෝ read කරා කියලා. Right? Why am I forcing you? Because that will give you some preparation, right? Preparation is one of the very important factor for science students. Prepare for your lessons, right? So when I told you that I'm going to have paper 2, so then study for it. Yes, we have one test, we have semesters, we have that and this, right? But you still can spend at least 5 to 10 minutes before this class, right? Ideally day before or 2 days before, ideally. පොඩ්ඩක් බලන්න බැලුවා නම් මම මේ lessons ටික brush කරාන then මම දැක්කා ළමයි තුන්දෙනෙක් ඇවිත්. ඒගොල්ලෝ විනාඩි 45 විතර කලින් එනවා class එකට. That's good. No? So then you can sit down and go through, right? So those small things will be added up at the end of the year, and that will give you big impact on your marks. Right? Ekin lamai prepare and join. Is that clear? All right. We have like a part of the to video in the part. Right? Okay, so let's move on. Next one. Silver is a transition element with proton number 47. Use the periodic table to state the number of occupied electron shells in an atom of silver. Then සමහර ළමයි මොකද දන්නවද කරේ? Periodic table එක බලලා මේක electron configuration එක ලියන්න හදනවා. මම ලියන්නේ තමයි මේක electron configuration එක. You can't write. Right? It's very difficult. Then you may be wondering, if you don't write the electron configuration, how do we know how many electron shells are there? Right? ඒක තමයි පොඩේ. Now, if you find something very complicated, what was my advice? Go to the basics. Very good. Go to the basics. What's the basic about periodic table? Group number tells you the last shell electrons. Period number tells you the number of electron shells. Right? So when you look at the period number, what's the period number of silver? That's the periodic table. It's not my periodic table. Five, right? So then it's in the group of period number 5. I'm planning to have a big periodic table based on the all next thing, right? Okay. Describe with aid of diagram metallic bonding of silver. That's so easy. I will show you the diagram after this. Let me keep that anyway. I don't like it. Okay. Right. So then so you put positive charge and electrons going, right? But anyway, that's very correct. Crystal structure. So these are the positive ions. My line is easy. These are the delocalized ions. And wait. 3 marks. One mark for the diagram, right? And closed effect positive, closed effect. It has to be regular, first of all, regular, right? And closed effect. Delocalized electrons, actually 2 marks, no? 2 marks per diagram. 1 mark for the positive ion label, the other mark, delocalized electrons label. And then saying strong electrostatic attraction between the positive ions For the cations and electrons, 1 mark. That's the definition of the metallic bond. කලින් මතක තිබ්බේ නැත්නම් දැන්වත් ලියාගන්න ටොක්ක්ක් යන ගන්න අනේ මේක මතක තියාගන්න කියලා. Right? Tell your brain. Right? මේ මතක තියාගන්න. This is simple stuff. No?
So the diagram 2 marks.
Yeah.
The
නේද diagram වල label කරන්න ඕනේ. Label කරලාද කියවන්න මේක. Don't just try to catch the word and maybe. And this is a metallic structure, high giant metallic, high melting point, high boiling point, high density. But there is one thing. All right. Only characteristic for transition elements, but not for all metals. I can't write conducting electricity here. Why? Conducting electricity is common for all the metals. But high melting point, high boiling point are not common for all the metals like sodium, mercury, they are out. Right? And electric conductivity is common. Right? High density is also out for sodium and mercury. Yeah.
the physical properties of catalyst.
Back. Catalyst oxidation state because transition elements have some specific properties. Right? Catalysts act as catalysts, colored compounds. They are what? They are chemical properties. Right? All right. So name the suitable combination of an acid and an insoluble base to prepare silver nitrate. They have told everything, right? No need to think, no need to worry about salt preparation that much. The acid is nitric acid. Acid is nitric acid. And the base is, it should be any insoluble base of silver. Right? So silver oxide. Silver hydroxide. Look, they have not considered silver carbonate. Carbonates are not bases. Carbonates are basic salts. You both got the highest marks and along with someone in the online class, right? Now they know do there was a student who wanted to get 100 for the chemistry. His only target is 100 for chemistry, 100 for physics, 100 for maths, right? In Cambridge. That's good anyway. There's nothing wrong with it. But when he writes the answers, he writes answers everywhere. Then make an answer. He writes like this. මුළු පොතේ තියෙන ඔක්කොම ලියන. ඒක මෙතනත් ලියලා මේම පොයින්ට් එකක් දාලා මේමත් ලියන අනිත් විශ්. I said don't write like this. Write only up to the point. Give you enough number of what? Points, that's enough. You get the full marks. Right? So there were instructions we gave. He listened to some instruction he didn't listen. Right? This is one and then marks came. He got only 94 for giving. Okay. So he was like upset 94 for him. Right? Okay. Like you are like over the moon for some kids. So he's very upset. He came to my place with my mother and said, "So, parents have been made up. Not really. I told you, I gave you some instructions like this. You must have definitely not followed those instructions. That's why you got. So we the paper. Okay. Then he brought the paper down, and then I went through exactly correct. Why? He has lost somewhere around 2 or 3 marks because he has written the answer somewhere else. Right, Manka? Okay, you do the recorrection. You ask for the recorrection, then they will like double check it and give the marks. Right? And that even he got 97. Right? Because one was completely wrong. The other one, he lost the mark for this carbonate thing. In the class, I told several times, don't write carbonates as bases in salt preparation. But we can use it. Carbonates are basic salts. If they ask insoluble base, write oxide or hydroxide. Right? If they ask a suitable combination of an acid and a solid, which is used to prepare silver, yes, then carbonates are all right. Okay. So these are very like micro details. Those who are really want to like nail this Cambridge paper to perfection, right? You can do it. There are, yes.
Sir, I have to know that I wrote the stupid number.
Yes, wrong is wrong. That you like, you could have nicely write silver hydroxide, and that is much easier writing the formula of that, right?
Sir, down.
Okay. හරි ඒවා හදාගන්න ඒ mistakes ආපහු කරන්න එපා. හරිද? Okay. Anyone needs more time for the previous slide? Anyone needs more time for previous slides? No one? All are okay? All right, next, silver nitrate is electrolyzed using electrodes. So that the moment they told you electrolysis, quickly break it into ions, right? H plus hydroxide ions, and silver ions are reduced at the cathode to make silver atoms. Up in, we did redox to a certain extent that you are not going to forget it, right? Especially electrolysis. And hydroxide ions. Now this one, I told you, don't try to logically write. I asked you to by heart this. Like I usually don't ask to by heart everything. Right? I ask this, you need to by heart the hydroxide ion. 4 hydroxide ions will become oxygen and 2 water by releasing 4 electrons. Right? Explain why solid silver nitrate cannot be electrolyzed, because it's a solid. Solid state ion cannot move. Solid state, in solid state, ions cannot move. So it is not enough. Electricity is not conducted. Electricity is not conducted. I don't know whether they accept only one part, but I feel like you have to say electricity is not conducted, so then it can't undergo electrolysis. Yeah. Golden rules මතක තියාගන්න නෑ ඔයගොල්ලෝ ඒකයි. I told you the conductivity of ionic compounds do not refer to electrons. ඔය විදියටම කිව්ව bonding lesson එක. For ionic compounds, their conductivity do not refer to electrons. Ions, whether ions move or not. Covalent compounds, yes, you can refer to what? Electrons, right? Metals, electrons, right? Acidified aqueous reacts with sodium iodide. Say the observations for this reaction. Okay, observation. Silver iodide is what? Yellow precipitate. Yellow madia, yellow precipitate liyanone. Silver iodide is a yellow precipitate. By treatment. Okay, next one. Explain why referring to the equation, this is a redox reaction. Now, this can be explained in many different ways. One, referring to the equation. So you can say magnesium in 0 oxidation state. Magnesium is in 2+ oxidation state. What has happened to the oxidation state? Increase. then oxidation. Copper here it's 2 plus. Copper here is 0. Element එක 0 නේ ළමයි. Therefore, can you remember that hint? Therefore, reduction. This is oxidation. So you can say magnesium has increased its oxidation state. Copper has reduced its oxidation state. So it's a redox reaction. Or you should remember if magnesium becomes Mg2 plus, it's going to remove electrons. If copper 2 plus become copper atoms, it should gain electrons. Right? So
it's reduced and gain in and against oxidation.
අනිත් පැත්ත ලියලා තියෙනවා. අනිත් magnesium is getting oxidized. අනිත් පැත්ත ලියලා තියෙන එක ගන්න. Right? Magnesium is getting oxidized, it removes electrons. Copper ions getting reduced because it gained electrons. Right? Construct ionic equation, that's so easy. Magnesium solid. දැන් ඒකවල physical state දීලා තියෙනවා. එතකොට ඔයගොල්ලෝ තියන physical states. හරි? And it will react with copper 2 plus. Sulfate ions are spectate ions. No change, same. So don't write it. And then magnesium 2 plus and copper solid. Displacement reactions. More reactive one displaces the less reactive one. Right? And pure copper can be made by electrolysis sulfate. Now, the most important thing is your anode and cathode polarity is shown and then correctly attached to the pure copper and the impure copper and the electrolyte. I'm giving my answer first, right? My explanations writing, and then I'll show you the mark scheme answer also, right? Empty page. This is plus, this is minus. This is anode, right? And this is cathode. And anode is impure copper. And cathode is what? Pure copper. And the solution is copper sulfate aqueous. You know that then the anode depletes, at the cathode copper ions will get deposited. Then we don't have to say. What observations are made when adding aqueous ammonia? Oh, that's a different story. Now you are testing copper ions. Initially you get the blue precipitate, and you know with ammonia you get that vibrant blue color. Don't write vibrant blue color, dark blue color. So then slowly mixing. No further change occurs. So no further change occurs means in excess. You had to put in excess. Right? Okay. So then you write blue precipitate, soluble in excess, not enough to give dark blue solution. To give dark blue solution. Right. And we have one more question to discuss, right? Yeah. Okay. Blocks of magnesium are attached. All right. Listen to me. We discussed this also. We have, let's say, underground water pipes. And these are made of iron, and these are maintained by the, let's say, whoever the responsible department. There are no such things in this country, but okay, right? So by fixing magnesium to iron. Why? When iron is going to react with oxygen by supplying electrons, magnesium says, how dare you react with oxygen when I am there, right? Because magnesium is more reactive and it is the one going to get oxidized by giving the electrons, right? So then those electrons, when iron tries to give electrons, magnesium send those electrons by getting oxidized, right? So what you have to write, why do we place magnesium? Because magnesium is more reactive. Magnesium is more reactive than iron. That one mark. So it gets what? So it gets oxidized or remove electron. Oxidize preferentially over iron. Magnesium corrodes instead of iron. Take a note. Preferentially over iron. Oh, sorry. නෑ marks දෙන්න එකක්වත් extra. Marks scheme එකේ එහෙම එකක් කියලා නෑ බලන්න. Anode and cathode is due to the way that I have asked you to remember that anode attracts anions. So anions are negative, therefore the anode has to be positive. Cathode attracts cations. In order to attract cathodes, cathode should be negative. Yeah, whatever it is, batteries, the positive side is the one that attracts anions. So that's the anode. Battery's negative side is the what attracts anions. Sorry, negative side is what attracts the cations. Therefore, it's cathode. It's oxidized. It oxidized first කියන වචනේ දීලා තියෙනවනේ I can give. Either.
Can you give additional marks?
හරි මාක් එකක් දෙන්න දෙයක් ස්ටාර් එකක් දාන්න. හරි කඩනවනේ ඒක.
Yes, sir.
All right. Done writing? Question number 6. Iron is attracted. Time to time there are some announcement time there today, right? Now we are not sharing the video link of the class video in the WhatsApp groups. Okay, we will be sharing that YouTube link for the class video in Microsoft Teams, the particular meeting chat. For example, in this meeting chat, this video's YouTube link will appear in 2 or 3 days time. So you can watch the video. If you miss any answers, writing answers, you can watch it. Right? We are trying our best to optimize our process so that you would get the best out of what we can do. We are doing our best. You guys are not doing your best. Right? Because now some of you are used to that. So you check in the Microsoft Teams. Okay? Right. Next one. And you're okay now?
Why did you open?
When you again have it, are you okay? All right, let's move on. Name and of iron. It was there at the beginning of the. All right. Explain by reference to the chemical reaction involved why limestone is used in the blast furnace. Limestone calcium carbonate undergoes decomposition to give calcium oxide and carbon dioxide. Carbon monoxide and we are right? Chemical reaction. Why limestone is so you have to start with what? Calcium carbonate. And this calcium oxide is then reacting with silicon dioxide to form calcium silicate, which is known as what? Slag. Right? And this slag will float on iron at the end, at the bottom part of the blast furnace that you can remove it. Is that clear? So let's see what sort of points they wanted you to write. Now you can see they haven't given marks for equations, have they? No. Before that, you might see hematite, limonite, magnetite, siderite, right? Where that some weird names. You will say, no, you don't have to remember all these things just in case a student has referred to some extra knowledge and written. That's why they have given the marks. They are expecting only hematite, right? Next, calcium carbonate limestone decomposes to calcium oxide. Because the electricity power cut again on the power taking. Okay. That's understood. Now let's say, like, what are the points they have given? Calcium carbonate decompose. Now this is the reaction and this is the explanation. You need to write that. And then calcium oxide reacts with silica. This is the reaction and that's the explanation. Right? So this is silica. Silica is acidic. And this is calcium oxide. I don't have to write the name. And calcium oxide reacts with silica because this is basic. And silica is acidic. So those are the points that you need to enter. And that slag form, it will float on iron. They haven't given marks for that. So anyhow, so out of these 5 points, 3 points are accepted. And those are the points that I used to tell in the class when I teach you the blast furnace, both in class and school, right? There is no difference. In the center of the blast furnace is reduced by carbon monoxide. So these are basically, they have asked our 2 reactions, haven't they, right? So they ask iron oxide is reduced by carbon to form iron and carbon. They are asking a new one, right? Write both the equation. This is our normal equation. The other equation is just basically displacement of iron from carbon. And they have given information. This is AO2. This is AO2. Why? You can't study and go to the exam to write that answer because we never studied a reaction like that. But this is AO1. This mark is AO1. AO1 means you study and go to the exam. You remember that because it was there in the textbook. The second one wasn't there in the textbook. So it's AO2. To answer AO2, you have to check the information. Iron 3 oxide, carbon, iron, carbon monoxide. They have told everything. Remember, no word equations accepted, state symbols accepted, no unbalanced equations are accepted. The equations must be balanced. You are in Cambridge O level, not in grade 7 or 8. Okay. When cold iron obtained from the blast furnace is brittle, how can this iron from the blast furnace be converted to mild state? Okay, so iron, this is iron. Look at this, iron. We call this pig iron. We call this pig iron. Pig iron is very brittle, hard but brittle. Brittle means like a brick. When you hit it hard, it will break into pieces. But metal doesn't break into pieces, right? Metals are malleable. Why this is such brittle? Because there are carbon, lot of carbon impurities there in pig iron. First of all, you need to get rid of them and put controlled amount of carbon, right? So you have proper amount of iron and then there are carbon, right? Okay, so what you have to do, remove carbon. You need to remove carbon. In order to remove carbon, you are going to send oxygen through it. Right? That is enough. Remove carbon by oxidizing it. ඔයාට කිව්වම මම මේ රියැක්ෂන්ස් විතරක් ලියලා හරියන්නේ නැහැ. එක්ස්ප්ලනේෂන් ලියන්න කිව්වම මොනවද කරලා තියෙන්නේ? ඔයගොල්ලෝ සමහර අයගේ තියෙන මේ weaknesses වෙනස් කරන්න නම් ළමයි I have to go to the traditional treatments. නේද? කියන සිංහලේ තේරෙන්නේ නැහැනේ. අම්මලාට හදා ගන්නත් බැරි නම් තාත්තලා හදා ගන්නත් බැරි නම් දැන් මම හදනවා මෙතන. හරි බලලා ඔයගොල්ලෝ හැදෙන්නේ නැත්නම් දෙනවා අත දිගහැරලා පාරක් අල්ලගෙන කියන දේ අහන්න බැරි නම් ඇත්තටම කරනවා රයිට් ඒක එක්ක ආයේ එක්ක නතර වෙයි මට ප්‍රශ්නයක් නැහැ එතන ඉන්නවනම් මම කියන විදිහට වැඩ කරන්න you can't see the board let me know have your discussions done. I want to see your papers. For discussions, leave paper එක තියලා යන්න අද යනකොට. හරි? I want to see how much the discussion you have written. All right. So have we done the discussion? Okay. So the new component is you are getting somewhere around 10 minutes break. Online students, you can finish writing and you can switch off the video and just walk around, go to washroom, right, and then come back and get ready for the paper. I'll be giving you paper at 7:30. Till 8:30, you are going to write the answers. Okay, right. Okay, so you can join at 7:25. Right, please join at 7:25. By the way, to avoid last moment rush. Okay, online students, you can join and the paper was given to you early. You can have it printed now quickly if you have the opportunity to do that, but you can't be late to submit the answers today. You must submit the answers before 8:30. Yeah? There is no exception for that. Online students, please put your videos and join. Hurry up.
Excuse me, sir.
Yeah.
Sir, can you send the paper to WhatsApp?
Yeah.
Because
Why?
when I try to open the chat, it says it's only for team members only.
Did you join as a guest?
No, sir, I couldn't see the meeting tile in the general, so I got the link sent. I joined from the link.
Yeah, I think even Ishaq doesn't have it, no? periodic table.
One question. Sir, this question can substance be used more than one?
Read the instructions. Periodic tables. Mauli, Minelli, Senushi, Julmika, and Asat, I can't see you. Okay, Asat have sent the. Kumandaran, Jesuit effort, Tekadan, otherwise. You have to compare your improvement from the last day. yellow answers. Okay. प्रॉब्लम है, क्या प्रॉब्लम है? you can answer the easy questions first. And then, but if you're answering the easy question first, answer them fast, right? To fact the time, the best thing is spend the number of minutes equal to the number of marks. Right? If it is like 3-mark question, try to answer it in 3 minutes. You have more than that, don't worry. But if you do like that, you are doing it in the proper speed. Online students, you should be submitting the answers now. I told you I can't give you extra time because I gave you the paper much early. It should be submitting the answers now. Please write your name and it's R30, name, date, and R30. Your time is up. You should be submitting the answers now. Right. I'll see you guys during the theory classes and next week revision class. Bye.